We are back for today's stream. Yesterday, it was a small mistake. I slacked off. I should not have done this. So, yes, tomorrow it will be a short stream, unfortunately, because as you can see, it's 11 p.m. and I need to sleep. A bit exhausted from work. So, yeah, I don't think I will try to solve some LeetCode problems today. I will just focus on learning Rust syntax because that's important. That's what is important, and so yeah, we are going to do this. We completed the struct chapter last week, and we are now starting the enums and pattern matching one. Let me just check that everything is going good with the stream. Looks like it is. Yeah. Perfect. Defining an enum where structs give you a way of grouping together related fields and data, like a rectangle with its width and height. Enums give you a way of saying a value is one of a possible set of values. For example, we may want to say that rectangle is one of a set of possible shapes that also includes circle and triangle. To do this, Rust allows us to encode these probabilities as an enum. Let's look at a situation we might want to express in code and see why enums are useful and more appropriate than structs in this case. Say we need to work with IP addresses. Currently, two major standards are used for IP addresses, version 4 and version 6, because there are the only possibilities for an IP address that our program will come across. We can enumerate all possible variants, which is where enumeration gets its name. Any IP address can be either a version 4 or a version 6 address, but not both at the same time. That property of IP addresses makes the enum data structure appropriate. Because an enum value can only be one of its variants, both version 4 and version 6 addresses are still fundamentally IP addresses, so they should be treated as the same type when the code is handling situations that apply to any kinds of IP address. We can express this concept in code by defining an IP addr kind. I don't like this name, but let's move on. An IP addr kind enumeration and listing the possible kinds an IP address can be v4 and v6. These are the variants of the enum. IP address kinds is now a custom data type that we can use elsewhere in our code. Enum values. We can create instances of each of the two variants of IP address kinds like this. Let4 is equal to, okay. Instances of each of the two variants, okay. Note that the variants of the enum are namespaced under its identifier, and we use a double colon to separate the two. Okay, so it's the same syntax as for namespaces and for calling an associated function in a struct. associated functions for me it's just a static method of a struct. This is useful because now both values IP add kind v4 and v6 are on the same type, IP add kinds. We can then, for instance, define a function that takes any IP add kind. Fn route IP kind, okay. And we can call this function with either variant. Route IP v4, v6, okay. Using enums has even more advantages, thinking more about our IP address type. At the moment, we don't have a way to store the actual IP address data. We only know what kind it is. Given that you just learned about structs in chapter 5, you might be tempted to tackle this problem with structs, as shown in listing 6.1. Okay. IP address, kind, and address. Sounds good actually. Yes, I remember that there is the spread operator like this to get all the attributes of a struct and pass them to another one when we want to do a copy, for example. And this might move the struct, if I'm not mistaken. Here we have defined a struct IP add that has two fields, a kind field that is of type IP address kind, the enum we defined previously, and an address field of type string. We have two instances of this struct. The first is home, and it has the value IP address kind v4 as its kind with associated address data of 127.0.0.1. The second instance is loopback. It has the other variant of IP address kind as its kind value v6 and has address column 1 associated with it. We have used a struct to bundle the kind and address values together, so now the variant is associated with the value. However, representing the same concept using just an enum is more concise. Rather than an enum inside a struct, we can put data directly into each enum variant. This new definition of the IP address enum says that both v4 and v6 variants will have associated string values. Okay. We attach data to each variant of the enum directly, so there is no need for... Wait, let me read because I don't think I have fully... However, representing the same concept using just an enum is more concise. Rather than an enum inside the struct, we can put data directly into each enum variant. This new definition of the IP address enum says that both v4 and v6 variants will have associated string values. Interesting. Representing the same concept using just an enum is more concise rather than... That's actually great to have. At least I like this feature. I can see how it can be useful. Also, before going more into this section, I just want to briefly go through the past sections and make sure that I remember most things that were given. I remember that about the derivation of traits. I think it's called the traits. Debug, clone, what else? Copy, I think. There was the trait debug and also the trait Um, an example, okay. I remember there is also the tuple struct, which seems to be pretty useful. Struct derive debug, the trait debug. It was the trait display that we should have implemented to print, but that we couldn't derive from the parent class, if I recall correctly. And you can use this debug macro to print it and get the file name and the line where the code is located. This program does not compile. rect1 is moved by calling so it cannot be used on the next line. Yes. So it cannot be used on the next line. Method syntax. Let's revisit. Yes, so we need to pass self. And we also have self with the S capitalized to reference the struct name. Build pattern. Where was the build pattern? I don't remember. Method syntax. Probably here, yes. Associated functions that are in methods are often used for constructors that will return a new instance of the struct. New, but new isn't a special name and isn't built into the language. Got it. So this is an associated function. Methods with more parameters and self to reference the current instance. Okay. And you can also add the mute keyword here with nself. Alright, that makes sense. Let's come back to the enum section. So from what we have seen is that we can define enums with fields and directly with data type. So for example, here we can say that v4 and v6 are strings, and we pass the string. So yeah, so this is like a struct inside an enum, or like it's a way to simulate a struct using an enum. This new definition of the IP address enum says that both v4 and v6 variants will have associated string values. Okay. We attach data to each variant of the enum directly, so there is no need for an extra struct. Here it's also easier to see another detail of how enums work. The name of each enum variant that we define also becomes a function that constructs an instance of the enum, that is IP address v4 is a function call that takes a string argument and returns an instance of the IP address type. We automatically get this constructor function defined as a result of defining the enum. we automatically get this constructor function defined as a result of defining the enum. There is another advantage to using an enum rather than a struct. Each variant can have different types and amounts of associated data. Version 4 type IP addresses will always have 4 numeric components that will have values between 0 and 255. If we wanted to store v4 addresses as 4 U8 values but still express v6 addresses as one string value, we wouldn't be able to, with a struct, enums handle this case with ease. I see, so if we want different types, we can use an enum instead of a struct. Yeah, this example is like particularly suited for enums. Really like that the Rust book took this example. We have shown several different ways to define data structures to store version 4 and version 6 IP addresses. However, as it turns out, wanting to store IP addresses and encode which kinds they are is so common that the standard library has a definition we can use. Let's look at how the standard library defines IP address. It has the exact enum and variants that we have defined and used, but it embeds the address data inside the variants in the form of two different structs, which are defined differently for each variant. Struct IPv4 address, IPv6 address, IP address, v4, v6. Public enum, IP address, v4, v6. This code illustrates that you can put any kind of data inside an enum variant, strings, numeric types, or structs. For example, you can even include another enum. Also, standard library types are often not much more complicated than what you might come up with. Not much more complicated than what you might come up with. Interesting, that makes sense. Is unspecified, okay. Note that even though the standard library contains a definition for IP address, we can still create and use our own definition without conflict because we haven't brought the standard library's definition into our scope. We will talk more about bringing types into scope in chapter 7. Let's look at another example of an enum in listing 6.2. This one has a wide variety of types embedded in its variants. Message, quit, move, write, change color. I see that there are multiple ways of creating enums. Like a lot. Change color. So this is the same as here, but this one is a bit interesting. It's a struct. This enum has 4 variants with different types. Quit has no data associated with it at all. Move has named fields like a struct does. Write includes a single string. Change color includes 3 I32 values. Defining an enum with variants such as the ones in listing 6.2 is similar to defining different kinds of struct definitions, except the enum doesn't use the struct keyword and all the variants are grouped together under the message type. The following structs could hold the same data than the preceding enum variants hold. Struct quit message. Unit struct. I forgot this, that we can define void structs. Let me come back struct void empty. Build user. So that's all right. Let me. So I was looking for the empty struct and I cannot find it. I'm pretty sure I have seen it before, but I don't remember where it was. Rectangle doesn't implement, no. I guess I will not find it. I forgot also about this, that the dot is replacing the dot and the arrow operator from C and C++. Rectangle, fn self, okay. Now I think I don't see where we have seen the empty struct here. Anyway, let's continue. Unit struct, this makes sense. Struct write message, tuple struct change color message. But if we use the different structs which each have their own type, we couldn't as easily define a function to take any of these kinds of messages as we could with the message enum defined in listing 6.2, which is a single type. There is one more similarity between enums and structs. Just as we are able to define methods on structs using impl, we are also able to define methods on enums. Here is a method named call that we could define on our message enum. Wait. Here is a method named call that we could define on our message enum. Interesting. So, interesting. The body of the method would use self to get the value that we call the method on. In this example, we have created a variable m that has the value message write string from hello, and that is what self will be in the body of the call method when m.call runs. Let me read because I'm not sure that I have fully understand the logic. The body of the method would use self to get the value that we called the method on. In this example, we have created a variable m that has the value message write string from hello. But where is the write coming from? And that is what self will be in the body of the call method when m.call. Is it because of the write? Has the value string from hello. Tuple structs. We are also able to define methods on enums. Here is a method named call that we could define on our message enum. The option enum and its advantages over null values. This section explores a case study of option, which is another enum defined by the standard library. The option type encodes the very common scenario in which a value could be something or it could be nothing. Let me just ask ChatGPT, what is the right part of an enum doing? And let me create a new chat so that we don't get influenced, so that ChatGPT doesn't use the previous chat. Is not specific to enums, but is instead a way to referring. Why didn't I say that on this in Rust? What is the right part of an enum doing in Rust? In the language, in the programming language Rust. In Rust, the syntax is used to access items in modules such as structs, enums, and functions. When used with an enum, the syntax enum name enum value is used to refer to a particular variant or member. Really? Is it because write message? Okay, I fight. Okay, now I understand. So because this write is referring to this one. Quit, move, right, change color. Okay, now I understand. And can you chain? I'm actually interested to test what it's doing. Cargo new tuples. Why is it tuples? It's enums. Open folder enums. Let me copy this. Cannot find message in the scope. Variant and move are never constructed, so it seems that I need to copy this too. Or actually no, it's works, it's just a warning, it's not an error. So can I chain things like quit and say that this is maybe change color instead? No, it doesn't look like it's possible. Let home. Damn, I'm trolling, guys. An enum is it's like I'm trolling. Like this doesn't make sense because an enum is containing one of the field. It's like a one of these messages. It's not a struct. That's what an enum is doing right. and listing the possible kinds of an IP address. Okay. So all the possible variants. Alright. Let's look at another example. Let's look at another enum in the standard library that is very common and useful option. The option enum and its advantages over null values. This section explores a case study of option, which is another enum defined by the standard library. The option type encodes the very common scenario in which a value could be something or it could be nothing. Okay, we have read this part. For example, if you request the first of a list containing items, you would get a value. If you request the first item of an empty list, you would get nothing. Expressing this concept in terms of the type system means the compiler can check whether you have handled all the cases you should be handling. This functionality can prevent bugs that are extremely common in other programming languages. Programming languages design is often thought of in terms of which features you include, but the features you exclude are important too. Rust doesn't have the null feature that many other languages have. Null is a value that means there is no value there. In languages with null, variables can always be in one of two states, null or not null. In his 2009 presentation, Null References, the billion-dollar mistake, Tony Hoare, the inventor of null, has this to say. I call it my billion-dollar mistake. At the time, I was designing the first comprehensive type system for references in an object-oriented language. My goal was to ensure that all use of references should be absolutely safe, with checking performed automatically by the compiler. But I couldn't resist the temptation to put in a null reference simply because it was so easy to implement. This has led to innumerable errors, vulnerabilities, and system crashes, which have probably caused $1 billion of pain and damage in the last 40 years. I guess it's even more, like, in terms of value, if you consider, I would say it's even more. I would estimate that it would be much more than just 1 billion. The problem, because I guess by just having this, you have sometimes, I guess, some memory safety problems. And just imagine the number of people that worked on related memory safety work that would have done something else. And I would estimate that these people, plus the pain of all people that had vulnerabilities, errors, and system crashes, would be much higher. So I'd probably guess something between 10 and 100 billion dollars. Or maybe even more, because like I know that for in cryptocurrencies and smart contracts, there are ways to hack some smart contracts using related vulnerabilities coming from null references. The problem with null values is that if you try to use a null value as a not null value, you will get an error of some kind. Because this null or not null property is pervasive, it's extremely easy to make this kind of error. However, the concept that null is trying to express is still a useful one. A null is a value that is currently invalid or absent for some reason. The problem isn't really with the concept, but with the particular implementation as such, Rust does not have nulls, but it does have an enum that can encode the concept of a value being present or absent. This enum is option and it is defined by the standard library as follows. Enum option diamond operators with a generic key, and it has two values or two possible types, none and some of the generic type key. The option enum is so useful that it's even included in the preludes. You don't need to bring it into scope explicitly. Its variants are also included in the prelude. You can use some and none directly without the option prefix. The option t enum is still just a regular enum, and some t and none are still variants of type option t. The T syntax is a feature of Rust we haven't talked about yet. It's a generic type parameter, and we will cover generics in more detail in chapter 10. For now, all you need to know is that T means the sum variant of the option enum can hold one piece of data of any type, and that each concrete type that gets used in place of T makes the overall option T type a different type. Here are some examples of using option values to hold number types and string types. Let some number equal some 5. Let some char equal some e. Wait, let me read, because why would you define e like this? Like more doing these affectations, using some, and I should stop saying like. I know it, and I should not. Here are some examples of using option values to hold number types and string types. Let absent number option i32 equals none. So if I understand correctly, if you have a function that has an option return type as let's say a string, you would need to return some of a string, like here. The type of some number is option i32. The type of some char is option char, which is a different type. Rust can infer these types because we have specified a value inside the sum variant. For absent number, Rust requires us to annotate the overall option type. The compiler cannot infer the type that the corresponding sum variant will hold by looking only at a non-value. Rust requires us to annotate the overall option type. The compiler cannot infer the type that the corresponding sum variant will hold by looking only at a non-value. Here we tell Rust that we mean for absent number to be one of type option i32. When we have a sum value, we know that the value is present and the value is held within the sum. When we have a non-value in some sense, it means the same thing as null. We don't have a valid value, so why is having option any better than having null? In short, because option and the generic T, where T can be any type, are different types, the compiler won't let us use an option value as if it were definitely a valid value. For example, this code won't compile because it's trying to add an i8 to an option i8. if we run this code, we get an error message like this. Cannot add option i8 to i8. Instance. In effect, this error message means that Rust doesn't understand how to add an i8 and an option i8 because they are different types. When we have a value of a type like i8 in Rust, the compiler will ensure that we always have a valid value. We can proceed confidently without having to check for a null before using that value. Only when we have an option i8 or whatever type of value we are working with do we have to worry about possibly not having a value, and the compiler will make sure we handle that case before using the value. It reminds me something coming from the Java, the option type too. Java type. And I remember that during one of my previous internships, I used to have this frequently in my codes. And it was actually nice to use options. So I'm looking forward to use them in Rust. In other words, you have to convert an option T to a T before you can perform T operations with it. Generally, this helps catch one of the most common issues with null, assuming that something isn't null when it actually is. Option type in Python. Option type in JavaScript. Creates a new HTML. No, it's not what we're looking for. I really enjoyed using the option and either monads in Scala. Are there any equivalent for these things in Python? If there aren't, then what is the Pythonic way of handling errors of absence of value without throwing exceptions? The Pythonic way for a function to say I am not defined at this point is to raise an exception. One may also use none versus actual value you want and enforce it with discipline. You can play with typing package. Using following makes type checker happy. Alright, let's come back to Rust. We're not here to learn about Python, but about Rust. Eliminating the risk of incorrectly assuming a not null value helps you to be more confident in your code in order to have a value that can possibly be null. You can safely assume that the value isn't null. This was a deliberate design decision for Rust to limit null's pervasiveness and increase the safety of Rust codes. So how do you get the T value out of a sum variant when you have a value of type option T? So you can use that value. The option T enum has a large number of methods that are useful in a variety of situations. You can check them out in its documentation. Becoming familiar with the methods on option T will be extremely useful in your journey with Rust. In general, in order to use an option T value, you want to have code that will handle each variant. You want some code that will run only when you have a sum T value, and this code is allowed to use the inner T. You want some other code to run if you have a non-value, and that code doesn't have a T value available. The match expression is a control flow construct that does just this when used with enums. it will run different code depending on which variant of the enum it has, and that code can use the data inside the matching value. Let's do the quiz. Question 1. Determine whether the program will pass the compiler. If it passes, write the expected output of the program if it were executed. fn foo. So we have a function foo that is taking a reference to an assigned integer of 32 bits, and that prints its value. Let x is equal to null. It does not compile because there isn't any null type in Rust. Consider these two representations of a result type that contains a value t if a computation succeeds, or an error e if it fails. The enum result2 is considered more idiomatic than the struct result1 in Rust. Which statement below is not a valid reason why? Result2 is more idiomatic than. The struct could have OK and error both be known, while the enum must have at least one of them. Is not a valid reason why. The struct contains options types which statement below is not a valid reason why. So if I understand correctly, I need to find a statement that is an invalid reason why result2 is not. I need to find a statement that is not the reason why result2 is considered more idiomatic than the struct result1. The struct contains option types which are only intended to wrap structs. Contains option types which are only intended to wrap structs. The struct uses more space in memory at runtime than the enum. This is probably true. The struct is more syntactically verbose to construct than the enum. The struct could have OK and error both be known, while the enum must have at least one of them. The struct contains option types which are only intended to wrap. This is the reason why. Correct and correct. Alright. Alright, it's almost midnight, which is pretty sad. What should I do? Actually, I think I will reserve this section for tomorrow. I will probably just do some LeetCode problems, the easy ones. I completed this one in Python today, so maybe we can try to code this one in Rust. It's the daily one. But actually, let's solve this one using Python and then Rust to make sure that our logic is true first. Given two non-negative integers low and high, return the count of odd numbers between low and high inclusive. The constraints: low and high are integers between 0 and 10 power 9. And low is less than high. less than or equal. All right, so um, so you probably need firstly to have is low even, is high odd. So have two variables to determine if low and high are even integers or not. So what we can now do is, if this is different than that, so if is low even is different than is high even, we return low minus height divided by 2. I'm using the left shift operator here because, you know, we are a bit different than others. We don't do this. We use the left shift operator. For those who don't know what is this operator doing, is just shifting the bits. So let's say we have the integer 6 that is represented as this binary 0b. Is this like that? 0b. And so what it does is just taking this bit and removing it. So left shifting to the right. And so this would become 3. And it's a way to divide by 2. Because yeah, what happens is that when you divide by 2, you shift the last bit. It's like you remove it. You shift all your bits to the right by 1, which is the same as dividing by 2. And otherwise, actually, let's say that ans is instead this, and I will do the different. I wanted to do the XOR, but I think it will be easier if I do the equal. If is low even, and if is low even, then I can increment ans by 1. Because let's say that I have 1 and 3, low which is equal to 1 and high that is equal to 3. It means that here I need to output 2. But when I do 3 minus 1, actually I reversed it. It's high minus low and not the contrary. It returns 1 and we need to add 1. Return ans. So I guess we can do like this to be even more concise. And hopefully this should run as expected, and if it works, then we will shift to Rust. Easy problem. Damn. That's sad actually. Alright. It's embarrassing, guys, to struggle on an easy LeetCode. Why is this not working? So 21, it will be the same as 20 and 21. I wanted to do it in a clean way. I could just, and in a fast way, I could do the for loop, but it's not great. If is low even, I think I'm doing the negation part, which is not what we want. If is low even, or is low even, or is high even, then I can increment by 1. Or not. I think it's because I confused odd and even in my conditions. But let's verify. Wait. Let's say that I have 1, 2, 1, 3, 2, 4. So this will give me 1 because this condition will be true. This will give me is low even. Will give me true too because these two, one of these two conditions will be true. And this would give me 1. Because this would not be true. Is low even? No. Actually, I could do the negation of this. If not, wait, I think I'm trolling a bit. If not, I think I have an extra condition that I can just remove because if this condition is true, or not is low even, then we increment by 1, right? I think that makes sense to me. High, low. We did it, but yeah, it took some time, which is quite embarrassing. Is low, high. Not. We were applying a De Morgan transformation, guys. It shows that uni is not as useless as we might think. If not and is low even. Yay. So now let's code this in Rust. Let is low even low modulo 2 modulo 2 is equal to 0 is high even so the condition was if not is low is equal to is even and what? Actually, probably I can remove this. I can remove this extra parenthesis. Is low even, then let's mute ans is equal to is high even is low even, wait, high minus low with a shift of 1. Did I do a mistake? Yes, I did one. I didn't add this inside the parenthesis. Nice. Is there a better way to do it? Let's check. High plus 1 divided by 2 minus low divided by 2. Yeah, it looks easier actually than what I did. High plus 1 divided by 2 minus low divided by 2. First is odd. Sounds good. Okay, so now let's do this one, add binary. I solved it also an hour ago in Python, but let's do it in Rust. So I also need to output a string. So firstly, let me my solution high minus low plus 1 plus low and 1. Interesting. Let me take it and try to understand it. High minus low plus 1 plus low and 1, and we shift by 1. I see. So this you just get the difference plus 1, okay, and you check if low is an odd number, and if it is, then you increment it by 1 and you divide all by 2. Yes, sounds good. I like it. I'm not sure if you can do even better than this, but let me think. Sounds probably one of the best solution. Good job. Yeah, I don't think you can do less operations. It works, yes. I mean, to be fair, like this should work in most languages actually. Like in Java, I'm sure it will work too. I coded it in Python, but same concept. Yes. High, low, 1. Pretty sure if you go in give me a language in one of these lists. Like I'm sure, for example, in TypeScript it would work. It's like the syntax. You just need to have a return, but it would work because all these operators, minus, plus, the bitwise end and the bitwise right shift are like universal. High minus low plus 1. Okay. Good job. Okay, so now let's do this one. Add binary. Convert an int to string bursts. str.parse.unwrap. Okay. To string. I forgot that this works. Parapapam. Yeah, I guess we can preview this. So at the end we'd have let mute ans of type u64 10 power 4. Yeah, I think we can then have a u16 here to minimize all the costs. And so we would have ans.toString here. Let me just see if this works or not. A primitive type. That works. Okay, so let's firstly define. So the approach is to put pointers at the end of each string and iterate backwards. Have also a carry variable, and at each bit, if we still have bits left, we add them to the current sum and see if basically it's pretty easy. You just need to, like, for these types of problems where you need to add binary or digits from strings and you cannot convert the strings to numbers, you can just use some, you need to think about using the carry approach. Let's mute a index. -1. Let's beat shift beat. What else do I need? I think that's it. Yes, so while what? While a index is greater than or equal to 0, or b index is greater than or equal to 0, or carry is greater than 0, then what we do is get the current sum. Let sum is equal to a of a index. Wait, let's firstly put sum to carry. I remember this from my previous codes. If a index is greater or equal than 0, then we can add to sum a dot a index. We do the same for the current b bits. Ans plus equal sum and 1 shifted by shift bits or weights. Yes, shift bits. Shift. Yeah, actually maybe I can optimize this by or actually it's fine. Shift index, and then we start it to 0 actually to not get rid of any problem. And so then carry is equal to some modulo, not modulo, but it's more like a division by 2 or right shift by 1 bits. So I think this works. Let me verify. I know that, yeah, there is a redundant variable here that we can merge, so we can have we can merge the carry and the sum, but let's see. Forgot to wrap this with parenthesis. And with a semicolon. Cannot be indexed by usize. In this scope. Cannot be indexed by usize. Oh yeah, I forgot also to decrement a index and b index. shift bit in the scope, solution.rs. Not found in the scope. Maybe it's because I'm tooling actually. Cannot be indexed by usize. Alright, so let's say that's I think it's because I forgot. Get convert get the char as bytes as char. The chars the chars dot env index dot unwrap. If I'm not mistaken with the syntax. Let's double check. Chars env I forgot parentheses because this is a function. I need to parse also this character. Parse character to int rests. Dot parse u8. Dot parse dot unwrap. What is the unwrap function doing in Rust? What is the unwrap function doing in Rust? Is a method that is available on the result and option enums. It is a convenient way to retrieve the value stored inside the results or option if the value is present, or to panic if the value is not present. I see, so that's actually what we need for my next that's actually what we will see in the next section here, I guess. Concise control flow with if-lets, or like one of these sections, pretty sure, with the unwrap arrays. So what was, okay, yes, I need to parse. Dot parse dot unwrap. That's a long lines, or like that's a long transformation to take just one character at a string. Sigma mail rest grind sets, exactly. And actually we can try to parse this into lower unsigned integers. U1 Rest. U1 integer. Push toy. Parse method not found in char. Parse a character to int rests. 2 digits. Char 2 digit then. Regix unwrap. Awesome. Oh, that's actually very good because you don't need to allocate more bits than you need. Maybe I can also get rid of this unwrap, but I'm not sure if it is too much or not. Expected U16 found U32. And maybe also carry should also be a U32. Or maybe not. Actually, we can reduce this to U8 probably. Because the carry will never be more than 2. Expected U16 found U32. And why is it expecting a U16? Shift index. Cannot add a sign. Expected U8 found U32. As U8. As U8. Expected U16 found U8. As U8. Wait, it's the shift index. Yeah, and so the shift index should be a U8 because it's never going to be more than roughly 10. Expected U16 found U8. Maybe I should cast everything this as a U16. Becomes quite ugly actually. Cannot assign twice to an immutable. That's true, I forgot that sum is an immutable. Option.unwrap on a non-value. Why is this non? That's actually sad because I'm checking that the indexes are above or equal to 0. C the 2-digit 10. Maybe I can get rid of some unwraps. Unwrap. Parse a char as a bits. Two digits. Radix. Converts a digit in the given radix to a char. Here is sometimes also called a base. A radix of 2 indicates a binary number. This is what I want. A radix of 10 decimal and a radix of 16 hexadecimal to give some common values. Arbitrary radices are supported. Method not found in option. I should probably need to really do the unwrap. My question is, why do we get a non... env0 with next. You could replace env0.next. Since if the string is empty, your program will panic. But why would it be empty? Or actually, maybe we should use the unwrap, because we want the program to panic if, like here for example, we want to panic to avoid graceful errors. But why cannot I convert? Maybe I can just do a println b.chars dot env p index line 17. A index. This is what I need. You are only expecting two different chars. You are expecting two different chars. Yes, 1 and 0. But the char 1 and the char 0. But I'm not sure what's the problem here. The problem is coming from dot unwrap. So you cannot just check for them explicitly. You are only expecting two different chars, so you cannot you just check for them? Okay. Is ugly. I, char is equal to 0. I could do that, but I would want to rely to have the two digits, to use the two digits, because yeah, like let's say we extend the problem, and instead of having binary, we have a number in base 3 or in octal, and then it will be um, like I'm not going to check for like I agree that this solution would work, but I find it not super nice. Like I want to also understand more the built-in functions so that I get familiar with them. But yeah, I'm wondering like what's my problem actually. Um, option that unwrap like one. Um, mm, it sounds like there is a is never nice, lol. Dealing with strings is never nice. Yeah, I can see why it's not nice in Rust. Or maybe it is just that I don't know the functions. It sounds like there is like a variable moved somewhere and I cannot spot where. One. Why am I doing this actually? Why am I not doing the prints properly? B index, A index. That's probably the reason why we have a B index which is a bit how can I say it? Quite big as a number. But how did I get this B index? I'm fucking idiot, guys. I should do the increment inside the. Alright. A U64 max, yes, because we do 0 minus 1. Wait, it didn't solve the problem. But because even though if I decrement outside of the if blocks, it should still not be catched here. Like it should not pass because. Okay, that's the. Alright. That's probably why actually because. Okay, it's because I'm using a U64 and okay, fucking idiots. I don't want to use a signed integer, and I'm wondering how can I achieve this without any overheads. Um, hmm. How can I get rid of? If you have any idea in the chat of how to deal with this without using a signed integer, I'm taking the I'm taking it. And actually I should also prefix this as u8. Like I could use this, which would solve the problem. Yeah, I think I will take this solution actually, because it's not that worse. Just do logic and characters. Let's not do it. Let's do it properly. B index as u size. And it's not even working. Yes, because I need to also convert this to a binary. Convert an int to binary in Rust. Dec to bin. To dot unwrap. Format -16. I think that's what I need. Return, or I can just ans as a binary. It sounds good, guys. And I also should stop saying guys. Like, it's a bad habit. Format into binary Rust without. What is my problem actually? I think it's because I have trailing zeros. Wait, what? I think the format function is not what what like the behavior is not what I'm expecting. Like, to be fair, I could do it, like code the function by myself, but I find it quite tedious, so let's find something better. Convert an int to string in binary form as string in Rust. Maybe actually I should just ask ChatGPT. How do I convert a string in an integer in Rust to a string representing the binary representing its binary representation. In Rust, you can use the format macro and the radix formatting trait to convert an integer to a binary string representation. Here is an example. Is this not what I just did actually? Note that the radix trait supports for formatting integer in other bases as well. Or is the problem with my logic actually? I don't think my logic is wrong. Shift index. I think I know where's my problem. It's, I think, coming from here. usize. No, it's not. A index. U16. So I have less zeros. Println. Are you accounting for any remaining value in carry? Yes, it's done here and here. So the idea is that I at the end of each iteration get the carry by dividing the sum of all bits by 2. This is a right shift by 1, right bit shift by 1. Like 11 should be enough. Like 1 should be enough, yes. What's weird is that when I format, or probably when I do some incremental. Maybe I think maybe it's related to types. I didn't type well the everything. I should use U64 because I wanted to use less memory. Why am I doing this? Println format. This is going to fail, and I want to know for which number it is failing. 23. That's actually very weird that I'm stopping at 23. Also, I can remove these types and type annotations. U16. What should I debug to understand better? Probably by printing the shift index and see what's there. Sum of 1. I will save the test cases next time it fails. Shift index 1. Shift index 10. So it's going to 10. Sum and 1. Follow-up question: can A index and B index be 0 while carry is greater than 0? Yes. Yes, definitely. When easy test case. So first iteration you will have A index, B index, like at the last bit, so it's going to be 1 1. The sum will be 2. It will make the carry equals to 1, because then we divide by 2. And when you go to the next iteration, you will have A index is equal to 0, B index is equal to 0, and carry equals to 1. Hope it clarifies the